I have been horseback riding for about 12 years now, and show jumping for roughly 9. I know, kind of a big deal. I've always been fascinated by the whole idea that both the rider and the horse are working together to cover the jump. It is truly about all the moving parts, meaning both the horse and the rider, working as one to reach their destination, which is the ground after the jump. This sparked my interest, and I wanted to share what I've learned about the subject.
Which is an excellent transition into Newton's first law and how it is applicable to horse jumping. An object at rest will remain at rest unless acted upon by an outside force, while an object in motion will remain in motion unless acted upon by an outside force. And to get the horse to stop is basically the rider pulling the reins back. So that's how we're going to get the force to stop moving. Again, Newton can help us understand horseback riding and horse jumping specifically with the formula force equals mass times acceleration. The mass is collective of both the horse and the rider on top of the horse, because it's two things moving as one to get over the fence. Acceleration is sparked because the rider asks the horse to speed up. Personally, I do this by simply clicking to my horse, but I use a crop to get him to accelerate more for a canter or faster trot if we are jumping. The horse cannot successfully get over the jump unless the speed is just so. If the horse is walking towards a jump, he will not get over it, and if he does, it will be rough. If he does get over it, it will probably just be a step. His body is too big to get over it without accelerating beforehand. This is all about the approach. The horse must remain at a steady speed, which is an average at 3.7 meters per second in our case. And just as they are in front of a jump, their neck reaches forward. Art Stinner of the University of Manitoba calls this relatively sudden braking action allows the predetermined momentum from the approach to carry the horse's body along with the rider over the jump. The horse wants to avoid face planting after it clears the fence, so as they take off from the ground, their weight shifts backwards. They must raise their head, shortening their neck to assist with moving the weights towards the rear of their body. Stinner says again, to slow the forward momentum as they land and reduce the force of impact, the horse will swing its neck and head as the forelegs reach the ground. The non-leading front leg hits the ground first. Once the leading foot lands, both legs push against the ground in backward direction. We know now that the rider has to be the outside force acting upon the horse to get it to go into motion, rather than it being an object at rest. So we know that we have the approach, in which the approach is the horse preparing at a consistent speed to be able to clear the jump, the actual approach, and then followed by the jump itself, ending with a safe mount, including the horse elongating its neck so as to prepare its whole body for the impact of the ground. Let's use kinematics to understand horse jumping. We'll solve for the final velocity. We need to recognize what our known variables are. In this case, it is velocity initial, time, and distance, leaving the unknown variable to be the final velocity, which we will solve for now. With the pre-existing variables that we had, it made sense to use the equation distance equals velocity initial plus velocity final over 2 times time. Once you plug in all of the pre-existing variables into the equation, you end up with the answer 1.2 meters per second as your final velocity. This makes sense considering the initial velocity was almost twice that amount. The reason the number changes so drastically to be so much smaller is because the horse loses energy as it goes over the jump, most of which was transferred to its rear end as it reached the ground. So most of the energy has gone away, and it doesn't quite reach the exact same momentum it had before, without help from the rider. This is truly a team sport, the team being the horse and the rider. So we have learned what the horse instinctively does, but what does the rider have to do? The common positions riders are in to jump is similar to crunches that Jane Fonda would tell you to do in a workout. This ensures that the rider is centered in the horse's center of gravity and will not lose balance off of one side or off of another. Or the front. It's happened before. So how do people fall off if they are in the position they should be? It is not always user error. Sometimes horses get moody and refuse a jump, simply because they are tired or annoyed. But more often the rider was pulling the reins too far back, stopping the horse from elongating their neck. Again, what if you did all of that right? Chances are that your legs were not agreeing with your body and were not giving the horse leeway to open up one way or another to turn outside of the jump. But, of course, arms on the reins are not a problem if you jump with your arms out of the way entirely. It takes incredible balance to achieve this jump without reins. Newbies use reins as a means of balance as well as their steering mechanism. When you take the reins away, the horse is not hindered by anything pulling their head one way or another. So the horse actually prefers to not have any reins at all. Unfortunately, user error often makes the horse not be able to elongate as much as it should be able to. So riding without reins truly helps the horse to accomplish its mission to get over the jump in one piece. So we've learned about Newton's first and second laws and how they're applicable to the horse jumping. We've learned about the horse's approach, jump, flying in the air, and landing, the kinematics of horse riding, and how the rider has to be just as responsive. So that kind of wraps things up. So I hope I taught you something new, or at least something interesting to you at some capacity.